Today we're going to continue looking at factoring to solve. So once again, in order to factor to solve, you always want to have it in the form ax squared plus bx plus c equals 0. So if you don't have it where it equals 0, that's the first thought process. If I look at these first two examples, though, I see that they equal 0. So it's set up how I want. And now I can just think about factoring. So how do we factor? We look for a GCF first. X squared plus 8x plus 15 equals 0. I notice that because there's a 1 in front of the x squared, I'm not going to have a number in common because the 15 does not contain a variable. Looks like there is no GCF in this particular problem. So remember, I'm asking myself, what is going to multiply to the last number but add to the number in the middle? So if I'm thinking about numbers that multiply to 15, well, one of the numbers would be 5 and 3. If I add those together, I'm going to get the 8 that I'm looking for in the middle. So I know that when I'm writing out my factors, I'm going to have an x plus 5 for one of my parentheses and an x plus 3 for the other. But because this equals 0, now I want to set each of those parentheses equal to 0 so I can finish solving for x. Once again, I'm going to put that line going through the equal sign so I keep the equation balanced. In this first equation, I'm going to have to subtract 5 to get rid of it on the left. So that's going to give me then 0 minus 5, which is negative 5. And so x equals negative 5 is one of my answers. Over in the second equation here, I'm going to have to subtract 3 to get the 3 by its, or to get the x by itself there. 0 minus 3 is going to give me a negative 3. So here are my two solutions. Once again, I should always have two answers because x squared, that exponent of 2, tells me I have two answers. All right, if I take a look at the next one, 3x to the third minus 9x squared equals 0. Once again, it's set up to equal 0, so to factor, we look for our GCF first. Looking at numbers, I notice that 3 is smaller than 9. 9 is 3 times 3. So they definitely have a number in common, and I know that there will be at least a 3 for a GCF. If I start looking at the variables, they both have x's. So then it's just a matter of how many x's do they have in common. X to the third, think about it as, okay, that's x times x times x. When we have x squared, that's x times x. So there's two x's in the last term, and there's two x's in the first term. So it looks like x squared is what they have in common as well. So 3x squared is the GCF. Now I have to figure out what is left over. So in the first term, I took out a 3 and I took out two x's, which means I'm just left with an x. I'm going to bring down that subtraction sign. I can ignore the 9 because that got broken up into 3 times 3. I took out the 3, so I'm left with a 3. And notice that because it was x squared and I took out both the x's, there are no more x's left over. So now that I've factored out a GCF, I notice that what I have in parentheses, I won't be able to factor it any further because it's not like the first problem where there's an x squared, an x, and a number. So that means that I've done as much factoring as I can. I now just need to set each factor that contains an x equal to 0. Notice that in this problem, my GCF, it has a variable. So that 3x squared, I get to set that equal to 0, and I can solve for x. The other factor is the x minus 3. So I get to set that equal to 0. All right, notice that the 3x squared equals 0. I need to get the x squared by itself, so I'm going to divide both sides by 3. That gives you x squared, 0 divided by any number 0. This should take us back to the last section, 9.3. Remember, once we've isolated an x squared term by itself, to get rid of the square, we have to take the square root of both sides. Square root of x squared is going to get you that x that we want by itself. the square root of 0. Now remember, because I take the square root, I normally have two answers, both a positive and a negative. In this case, though, square root of 0 is going to be 0, and there's no such thing as a positive 0 and a negative 0. However, I technically have two zeros. I just don't have to write it twice. Over here in the second equation, I'm going to add the 3 to get that by itself. That gets rid of the 3's. The x's alone. 0 plus 3 is 3. So even though it only looks like I have two answers, remember that exponent was a 3 to begin with. That was the biggest exponent. I do technically have three answers. It's just that this 0 right here, there are two zeros. I only have to write it one time though. All right. If I take a look at this next example, x squared minus 11x equals negative 27. Hopefully we notice right away that, hey, it doesn't say equals 0. So I'm going to draw my line going through the equal sign. Because I want x squared to be positive, I'm not going to move the x squared, which means the only thing I need to do to get one side equal 0 is move the negative 24. The opposite of a negative 24 is a positive 24. So I'm going to add 24 to both sides. That gets rid of it on the right, and now it'll say equal 0. On the left, I don't have any like terms. So that would give me then x squared minus 11x plus 24. Now we're back kind of to that first example in this video. Because I see that there's no number in front of the x squared and there's no variable with the 24, there is no GCF. So to factor means that I'm asking myself what is going to multiply to the last number but add to the number in the middle. Now, once again, this is where we have to be careful. Because I need to multiply to a positive 24, but I need to then add to a negative. Remember, a negative times a negative is also going to then add to a negative, but it multiplies to a positive. So if I do negative 3 and negative 8, a negative times a negative will get me that positive 24. And if I add negative 3 and negative 8, it's going to get me that negative 11 that I'm looking for. So we're going to factor it into x minus 3 times x minus 8 to equal 0. So I'm going to set each of those factors equal to 0, and I'll continue solving for x. So drawing my line down the equal sign, looks like we're going to have to add 3 to do the opposite there. So that gives us then 0 plus 3 is 3. Over here, we're going to add the 8. That gets rid of the 8's on the left. 0 plus 8 will give me 8. Notice that my original exponent is a 2. That's why I have two answers. All right, 5x squared minus 9x plus 4 equals 0. So good thing it equals 0. There's no need to do what we did in the last problem here. So now I want to look for GCF. 4 is the smallest number. I can't multiply 4 times something to get 5. 4 can get broken up into 2 times 2, but I can't find 2 times something to get 5. So even though I could break the 4, which is the smallest number, I can't find a number that they have in common. And because the 4 doesn't have a variable, but the other ones do, there's no GCF. So remember, that's that guess and check process. What's multiplying to 5? Well, luckily for us, only 1 and 5. So that means that we get to start one parenthesis with the 1x and one parenthesis with the 5x. Then I look at the last number. Notice that it's kind of similar to the last problem. If I want to multiply to a positive 4, but then in the end, I want to add to a negative 9x, well, then both of my numbers are going to be negative. So it's either negative 1 times negative 4, or it's negative 2 times negative 2. So this is where then the guessing comes into play. So let's guess. I'm gonna use, let's do the negative 1 and the negative 4. So if I do negative 1 first and negative 4 second, there's my guess. Now we have to check to see if I get to that negative 9 in the middle. So I multiply the outside terms. 1x times negative 4 would give me a negative 4x. Then I multiply the inside terms. Negative 1 times 5x is negative 5x. And notice that when I combine these like terms, I'm going to get that middle number. If I didn't, I would have to then try it again. Either reverse the numbers of 1 and 4 or use 2 and 2. But since this works, I then get to set each of those parentheses equal to 0. Once again, the number that is in front of the x, if it's a 1, you don't really have to write it. So it's just x minus 1 equals 0. And 5x minus 4 equals 0. All right, let's start solving. I'm going to have to add the 1 over to the other side. 0 plus 1 is going to get me 1. The other equation, we have to move the number not attached. So I'm going to add the 4. That gets me then 5x to equal 4. And then my last step is to divide by 5. Once again, 4 divided by 5 is not going to be the nicest number. Keep it as a fraction because 4 and 5 don't have any numbers in common. That doesn't simplify down any further. So 4/5 is the other value. Okay, here's a checkpoint problem for you. So go ahead, pause the video, see if you can factor to solve. All right, hopefully you factored to solve and you saw that there was no GCF. So it's just like the last example. You had to think about the guess and check process. So there's only one way to multiply to 2, 1 times 2. But notice that because we needed to multiply to a -7, I needed one number to be positive and one number to be negative. So it was either 1 times -7 or -1 times 7. So I did my guessing and I checked. I wanted to get that positive 5x in the middle. Ended up where the 2x had to have the positive 7 and then the 1x had to have the -1 to make that work. So then I set each of those equal to 0. And so my two answers should be -7/2 and a +1.